Hello and welcome to KG Tutorials. Subscribe and turn on the notifications now. In this linear algebra 2 lesson, we are going to discuss set identities. Okay, today we discuss set identities. Set identities are very important and useful in calculations of sets. So in today's example, we are going to use the U as the universal, set A, set B, and set C as the subset of the universal. Right, let's begin. We have the first one, which is the commutative laws. Under the union column, we have the union of A and B, which is equivalent to the union of B and A. So according to the commutative laws, it does not matter how our sets are united. At the end of the day, the results must be equivalent. The same thing applies under the intersection column. We have the intersection of A and B, which is equivalent to the intersection of B and A. So now it does not matter how our sets are intersected. It does not matter the order of how our sets are intersected. The result should be equivalent. Now we have the associative laws. Under the union column, we have the union of A and B and C, which is equivalent to the union of A and the union of B and C. Also here, it does not matter the order of how our sets are united. Now here under the intersection column, we have the intersection of A and B and C, which is equivalent to the intersection of A and the intersection of B and C. Also, the order in how our sets are intersected, it does not matter. The result should be equivalent. Okay. Now we have the distributive laws. Under the union column, we have the intersection of A and the union of B and C. Now, which is equivalent to the union of the intersection of A and B and the intersection of A and C. So if you can look at this, you will see that A is distributed to B and to C. That's why we have the union of the intersection of A and B and the intersection of A and C. Same thing applies under the intersection column. You will see that A is distributed to B and C. That's why we have the results of the intersection of the union of A and B and the union of A and C. Alright. Now we have the idempotent laws. Under the union column, we have the union of A and A is equals to A. Why is it the union of A and A is equals to A? Is because now we just have the repetition of subset, because now all those sets that are in A, the subset that are in A are also in A. Okay, so now that means the union will just be A. Now under the intersection column, we have the intersection of A and A, which is equal to A. So now here, all the subsets that are in set A are also the subsets that are in the set A. And then now the intersection of A and A will just A intersect itself. Okay. Now the absorption laws. Under the union column, we have the intersection of A and the union of A and B, which is equivalent to A. Alright, let's try on to explain this one better. Now, note here, this side we have the union of A and B. Okay, let me try to change some color. We have the union of A and B. The union of A and B is just the combination of A and B. Okay, so now that means in this case the union of A and B will contain all those sets of A and all those sets of what, of B. Okay, now since this side contains the subset of A and that side also contains the subset of A, that means the intersection of these two sets will be A. Under the intersection column, let's check on this side again. The intersection of A and B, it's empty. It's empty. Why is it empty? It's empty because A is not equals to B. So now all those sets that are in A are not in B. Okay, so now here we simply have the union of A and empty, which is equivalent to A. Why? Because now it's just like saying A plus 0, it's A. Okay, 1 plus 0, it's 1. Now we have the identity laws, which will explain better what we just talked about. The union of A and empty, it's A. Under the intersection column, the intersection of A and the universal. Now what is the universal? Universal is just all those sets that are available. All those sets that are available is the universal. Okay, so now where does the universal intersect with A? It intersects at A because the universal contains set A. Remember we said in the beginning of this lesson that A will be the subset of the universal. So now the universal and set A will intersect at A. Okay, now we have the universal bond law. Under the union column we have the union of A and the universal. What is the union of A and the universal? The universal is just all those sets that are available there, right? So now when we join A and the universal, we just end up having the universal because at the end of the day we will have all those sets that are available there. Then now we have that under the intersection column we have the intersection of A and empty. The intersection of A and empty is empty. Why? Because there's no way empty can intersect A, because empty is nothing. So there's no way they can intersect each other. So now the result will be empty. Now we have the De Morgan's laws. We have the complement of the union of A and B, which is equivalent to the intersection of the complement of A and the complement of B. Under the union column, under the intersection column we have the complement of the intersection of A and B, which is equivalent to the union of the complement of A and the complement of B. Now we have the complement laws. The union of A and the complement of A is universal. Why? Because A plus not A, the complement of A is not A. Okay, so A plus not A, that will be all those sets that are not A plus the set of A. It will be all those sets that are available there. That's why it becomes what? The universal. And then now we have the intersection of A and the complement of A. It's empty because now set A cannot intersect something that is not A. Okay, there's no way they can intersect each other. Now let's talk about the complements of the universal and the empty set. Okay, now we have the complement of the universal is equal to the empty set. Now we know that the universal contains all the sets that exist. Okay, so now what is the complement of the universal? Because now the universal is everything, okay? So now what is not everything? Because now on this case, in this case is what is not everything. If not everything, then it's nothing. That's why we end up having the empty set. And now the complement of the empty set is equal to the universal. What is not empty? If not empty, then it's full. If not nothing, then it's everything. That's why we end up having the universal as our answer. Now we have the double complement law. Now the double complement law is here we have the complement of the complement of A is equal to A. Okay, so now here we begin by having not A and not the complement. Not A, it's all those sets that are not in A, all those subsets that are not in A. Okay, and then now what is not the complement of A? Not the complement of A will be A. Okay, and then now we have the set difference law. Set difference law simply say here we have the set A subtract set B is equal to the intersection of set A and the complement of B. Alright, here when we subtract set B from A, we will end up having the intersection of A and the complement of B. Everything that is not B, because B is already subtracted from the set A. That's why we end up having not A. Okay, thank you for watching. Please like, comment and subscribe to this channel. You can also talk to me on kgtutorials@gmail.com. Have a nice and blessed day. Thank you.